So in today's lesson, we're going to talk about using the distributive property to simplify rational expressions. Now, a lot of this stuff is, again, we're adding on a little bit each time of the previous lessons and what we've been doing. So you need to pay special attention to what we're doing here in this lesson. Now, a rational expression is just an expression with a variable in the denominator. So anytime we have a variable in the denominator, it makes it a rational expression. So what we're going to do is we're using the distributive property. Again, if you remember what we've done with the distributive property is we take everything that's on the outside and multiply it by everything that's in the inside. So for example, let's take a look at example 1. We have x squared over y squared times x squared over y plus 3y cubed times or over m. Okay? Now again, this is going to look pretty scary. It's going to look like, wow, this is going to be hard to do. It's really not. Just pay attention. Remember the things that you've learned so far in this unit, and you'll be all right. Okay, we're going to do the distributive property, which means we're multiplying. And again, if you remember, when we multiply exponents, we add the exponents together. So in this case, we take x squared times x squared is going to give us x to the fourth. So then we take, and then we do the bottom, y squared times y gives us y cubed. Then we put our plus sign, and then we don't have, remember there's an imaginary 1 out here, so 1 times 3 is 3, and then there's no other x's, no other y's, so we're just going to take x squared, y cubed, over, and we're going to multiply y squared times m, y squared m. Now once we've done this, you can see that we, on the left side, x to the fourth, y cubed, everything's simplified there. But if we take a look at the other side, we have a 3x squared y cubed and a y squared m. Well, we have y's on both the bottom and the top. And if you remember, anytime we have a variable with an exponent on the top and a variable with an exponent on the bottom, we have to subtract them. So when we do this, we take 3 minus 2, and that leaves us with just y. So we'll take and we'll eliminate the y squared, and we'll eliminate the third here, and it'll leave us with a final answer of x to the fourth over y cubed plus 3x squared y over m as our final answer. So now let's take a look at example 2. Again, doing the exact same thing. We're just doing the distributive property. We're just going to go through a bunch of examples. That way you guys can see it and you can practice it. So we take a look here and we take m, we're doing the distributive property, so m times axp. Well, there's no other m's, and we don't have an a or an xp on the outside, so it's just going to be m a x p over, and then z times mk is going to be z m k. Now, the 2m to the fourth p to the fourth is actually going to be over 1. So we'll put our minus sign, and then remember we have a 1 in front of here, so 1 times 2 is 2, and then m times m to the fourth is m to the fifth, and then we just tack on the p to the fourth because there's no p's on the outside, and then z times 1 is z. Now we have maxp over zmk minus 2m to the fifth p to the fourth over z. We look on the left side over here, and we see that we have two different m's here, so we can cross those out. Those will cancel out just like that, which would leave us with an axp over zk, and the other side is minus 2m to the fifth p to the fourth over z. There's nothing we can cancel out there, so our final answer would be axp over zk minus 2m to the fifth p to the fourth over z. Now for example 3, this is where it gets a little bit trickier, but if you just pay attention, it won't be so bad. We have b to the third over d to the negative third times 2b squared over d minus f to the negative third d over b. Well, the best way to do this is just take anything we have as a negative exponent and just take it and move it to the top or move it to the bottom. So we'll go ahead and we'll move d to the negative third to the top, and when we do that, we're going to get, I'm going to erase this now over here, we're going to get d to the third. So we have d to the third over here outside now. And the f to the negative third would move it to the bottom over here. So by doing that, we'll erase this. We'll move it to the bottom to become f to the third. Now we can just do our distributive property and just solve the problem. So again, this is going to be over 1. So b to the third d cubed. Remember, there's a 1 in front of here, so 1 times 2 is 2. And then b cubed times b squared is b to the fifth, and leaves it with just a d cubed over d minus, we don't have a b here, so it's just be b cubed, and then d cubed times d would be d to the fourth over, and then 1 times f cubed b would be f cubed b. And then from here, we're just going to go and we're going to simplify each fraction. So we can get rid of the d here, because 3 minus 1 is going to be 2, so this would leave us with a 2 here. And then we can get rid of the b down here and turn this b cubed into a 2, because, again, 3 minus 1 is 2, which would leave us a b squared on top. This would be as simplified as it would get. So our final answer would be 2b to the 5th d squared minus b squared d to the 4th over f cubed. Now for our last example here, we don't have any negative exponents, so we're just going to go through and we're going to simplify each one of these. So ab times axp is going to give us a squared, and then we have a b, x, and a p. Then we c squared times c would give us c cubed. Plus, again, there's a 1 in front of here, so 1 times 2 is 2. We don't have any a, so we'll just leave the a there. B times b is b squared, and we have the x. Over, again, this is over 1, so c squared. Minus 4, and then we have to put the ab there, over c to the 4th. Now we look and see if we can reduce any of these. We look and see there's nothing that we can reduce, so our final answer would be a squared bxp over c cubed plus 2ab squared x over c squared minus 4ab over c to the 4th. Again, these are problems look really hard, but as long as you're just following through with the things that you've learned in this unit, you'll be all right.